is on.
All right. We're trying this again. This is going to be the third time that I've done this today. Basically, I don't know what I'm doing, I guess. It's probably a safe way. So we're going to be taking a look at, just trying to start my software here. There we go. So we're going to be doing some physics 11 type stuff. And hang on a second. I just got to do this over here. Hey. 11 type stuff. And hang on a second. I just wanted to see that things were actually coming through. So we're taking a look at Newton's laws of motion. And these are the review questions. Woohoo! So welcome. I don't know if Colby is still there or not. Monitoring things over on the other side. So let's see if we can get this. Okay, I'll show my desktop. And here we're going to go through some of these questions and talk about the answers to this. All right. A forward moving car is coasting to a stop on a straight level road. The net external force on the car must be. So what do we know here? It's coasting, so the motor is not pushing it forward. It's coming to a stop. So it's not uniform motion. The net external force, well, so if we consider there's our road, here's our car. We're going to have a force of gravity. We're going to have a normal force. The engine's not keeping it going, but it's coming to a stop. So there has to be a force of friction that's going in the opposite direction to motion. So the net external force has to be backwards in this case. So this is Newton's first law for really law of inertia. For an object that rests remains at rest, an object in motion remains in motion traveling in a straight line if you have no net force acting on it. The net force acting on it causes an acceleration, causes it to slow down. So that's really what's happening here. All right. What force acts on an object of a mass of 2.5 kilograms and an acceleration of 4 meters per second squared? Now, this is dealing with Newton's second law, F is equal to ma. And in this case, the mass is 2.5 kilograms, and the acceleration is 0.4 meters per second squared. So 2.5 times 0.4, using my Casio FX 260 solar, gives us a value of 1 Newton. An object is given an acceleration of 5 meters per second squared by a force of 10 newtons. What is the mass of the object? So here again, we're using Newton's second law, F is equal to ma. But now we're going to find our force using our force and acceleration. So our force is 10 and the acceleration is 5. I can do that. It's going to be 2 kilograms. Dynamics. So what we're doing is doing the algebra, asking various questions based upon this formula. A dynamics cart of 0.2 kilograms initially at rest is acted upon by an unbalanced force of 3 newtons. The acceleration of the cart would be, well, our acceleration will be our force divided by our mass. So we'll have our 3 divided by our 0.2 kilograms. And 3 divided by 0.2, and that's equal to 15 meters per second squared. Question number 5. A book is lying on the table, and the table is exerting an upward force on the book, which is equal to the downward force exerted by the book on the table. This example illustrates, all right, well, it's not going to be Galileo's. Newton's first law is inertia. Newton's second law is F equals ma. Newton's law of gravitation, well, that's Gmm over d squared. The answer is going to be Newton's third law. Here we have our table, here we have our book. Well, we have a force of gravity acting downwards. That's supposed to be a G. And we have a normal force acting upwards. And this is supposed to be an arrow here. These two forces are going to be equal and opposite to each other. That's Newton's third law. For every action, there's an equal and opposite reaction. All right, I got to erase this manually. Scratch, scratch, scratch. Literally, I've done this 3 times. This is my 3rd time today going through all of these questions. I think that I would know the answers better. All right, the force necessary. Why you have 3 times? The first time, well, I'm learning. Okay, I'm learning. This I'm live streaming. It's different. So you could actually be watching right now. Anyways, the force necessary to accelerate a 2 kilogram mass at a rate of 5 meters per second squared. Well, F is equal to ma. Our mass is 2 times 5. So that's going to be equal to 10 newtons. When the space shuttle is flying in space, away from the influence of any gravitational fields, and this means that it's in free fall, it's in orbit, and it seems weightless. Okay. Universal gravitation tells us that every object in the universe is attracted towards every other object in the universe. So you're never away from gravitational fields, but we can be in free fall, which gives us the impression of not having gravity affecting us, but it's causing us to be in orbit. Its engines provide a thrust of 2.4 times 10 to the 7 newtons. So the thrust pushes the shuttle that way. If the shuttle weighs 2 times 10 to the 7 newtons on the surface of the Earth, that means on the surface of the Earth, the force of gravity is equal to 2.0 times 10 to the 7 newtons. And that's equal to mg. And g, we're saying, is 10. So our m is equal to 2.0 times 10 to the 6 kilograms. And they want to know what's its acceleration. Well, F is equal to ma. So a is equal to our F divided by our m. Our force is 2.4 times 10 to the 7. Our mass is 2.0 times 10 to the 6, and that comes out to be, when you do your Casio FX260 solar, are 12 meters per second squared. Suppose the only forces acting on a 12 kilogram mass are those shown in the diagram. The acceleration of the mass would be. All right, so this is the idea of our net force is equal to our mass times the acceleration. Hey, Tanner, you got a question? Okay, ladies and gentlemen, I'll be back. I'm live streaming right now. All right. Yeah. Sorry. Okay, I'm back. Please laugh. Third time doing this, and it's a complete, well, not a complete, but it's, all right. All right, so here we are. So we're talking about the net force here. And so if we're going to choose a direction to be this, choose that direction to be positive, they're acting on a 12 kilograms. So we have our net force is the sum of our forces. So we're going to have 60 newtons plus a negative 36 newtons because it's going in the opposite direction, equaling our 12 times the acceleration. So 60 plus negative 36, so that's equal to 24 newtons. And so we'll have 12, acceleration will equal 2 meters per second squared. And it's going in this direction, which is west. It's all west. All right, we get to erase. And move this up. What force would cause a 250 kilogram motorcycle to have an average acceleration of 2.2 meters per second for 3.5 seconds? All right. So F is equal to ma, and our mass is 250 kilograms times our 2.20 meters per second squared. Do that, comes out to be 550 newtons. But what about this 3.5 seconds? Where does that come in? Well, there is no time within this. We're being asked for the force. So if there was like velocity coming into this, then we might have to use the time to calculate a new velocity and so on. We don't have that. We just have the force. So this is an example where extra information is given. You could say to try and confuse you, but just to make sure that you understand, not all information is necessarily necessary for you to answer the question. I just wanted to make sure. Oh, really thin. Okay, we'll try that. A 2,500 Newton unbalanced force acts on a 50 kilogram mass for 20 seconds. What is the average acceleration? So F is equal to ma, so acceleration will equal, that's maybe too thin. Let's come back. Try that. So it will equal our force divided by our mass. So we'll have our 2,500 newtons divided by our 50 kilograms, and that works out to be 50 meters per second squared. Again, the 20 seconds, what's with that? We don't need it. We're not going to use it. 11, an airplane moves in a straight level flight at a constant velocity. Constant velocity, uniform motion. Acceleration is equal to 0. That means our net force is also equal to 0. So what is the net force acting on it? Well, if the plane has 1,000 kilograms and there's frictional drag of 1,800 newtons, is the net force really equal to 0? Because we've got this 1,800 newtons. Well, let's consider. Here's my airplane. So we have the force of gravity, and we have the force of the wings. We have the frictional forces. That's equal to 1,800 newtons, but we're also providing a force of our thrust as well. And that's going to be equal to our 1,800 newtons because it's a constant velocity. Net force is going to be equal to 0. An elevator weighing 1,200 newtons. That means we have a force of gravity of 1,200 newtons going down, sorry, 12,000 newtons going down. There's a cable, and there has a tension of 20,000 newtons. And then there's resistance to motion. Well, it's accelerating upwards. That means our force of friction of 5,000 newtons is also going down. The unbalanced force on the elevator is. Here we're just asking about the net force. So F net, well, what forces do we have? We're going to take upwards to be positive. That's our direction of our acceleration. So we'll say that's upwards positive. So we'll have 20,000 newtons plus a negative 12,000 newtons plus a negative 5,000 newtons. Negative 17 plus positive 20. So that's equal to 3,000 newtons upwards. E. There we go. A 10 kilogram mass is lifted so it rises with an acceleration of 2 meters per second squared. The net force exerted upwards is. All right, so we have here, I'm going to move this up. This is a really good question in terms of what it's asking. Because you can get sort of confused. And I come down to make the point that you always want to make sure that you are answering the question that's being asked, not answering the question you think is being asked. A 10 kilogram mass is lifted so it rises with an acceleration. So we can think of this. We've got our mass and it's being pulled upwards, and we're going to have a force downwards, and we have an acceleration that's going upwards. F net is equal to ma. And you might think, well, it's accelerating upwards, so we need to find the tension. Well, no, it's saying the net force being exerted upwards. So our net force is just going to be our mass, which is 10, times our acceleration, which is 2 meters per second squared, and that's equal to 20 newtons. So the answer is going to be B. If you went through and calculated got the force of gravity and what's the force of tension having to be pulling it up, that would come out to be 120 newtons, the 1.2 times 10 squared. And so you really need to be careful. This would be the wrong answer, because that's not what the question was asking. You've gone beyond what the question is asking. It's not that there's something bad about this, but it just wasn't what was being asked. So be really careful, because they're giving you this information here so you could calculate what the weight is and, going through. That's not what they're wanting. A cart weighing 490 newtons is pushed by a force of 50 newtons. The acceleration of the cart is. So we need to, F net is equal to ma. And the cart is 490 newtons. Well, so our F net is equal to 50 newtons. To calculate the acceleration, we need to know the mass. Well, this is not the mass, that's the weight. That's our Fg is equal to mg. And so we have to take this 490 and divide that by 9.8. And that's equal to 50 kilograms. So we're going to have 50 kgs times our acceleration. And so our acceleration then is 1 meter per second squared. Be careful. Make sure you're, again, answering the question that's being asked, not what you think is being asked. A force of 10 newtons acts on point P in a due east direction. So here's my point P, here's due east. There is my 10 newtons. Another force of 20 newtons acts on the same point in the direction due west. So here's my 20 newtons going due west. The net force on point P is, well, we're going to add these two vectors together. We have 20 plus our 10 in the opposite direction. That's going to be 10 in this direction. That's our resultant. So that's going to be 10 newtons due west. Okay, before we go on, I'm going to erase these things. Now you can always pause these things. You can rewind the video and go backwards so that you can refresh your mind, or if you're missing something as I go through. So we want to apply Newton's second law of motion given on the left with the solution on the right. So here we have a mass and acceleration. So that means we're going to be calculating a net force is equal to mass times the acceleration. We're going to have 2.5 times 3, and that's equal to 7.5 newtons. So we're going to have, here we have our net force, 7.5 newtons coming up to here. So the answer to this is D. Here we have force 1, which is 12 newtons east. And then we have 6.5 newtons west, which means we're going to have a net force in this direction. That's what we can have. 12 minus 6.5, that would be equal to 5.5 newtons. So that's going to be our F. Here we have a net force of 12 newtons and a mass of 2.5 newtons. So acceleration is equal to net force divided by m. So we'll have 12 divided by 2.5. So that gives us 4.8 meters per second squared. So that's our A. Here we have a net force and an acceleration. So mass is equal to our F net divided by A. So we're going to have 2.5 newtons divided by 3 meters per second squared. And that's equal to 0.833 kilograms. And so that is our 833 grams. There we go. 16 to 19. Let's go through. All right, here we go. What is the tension in the rope? Now, this is a multiple choice question. There's a fair bit of calculation that we have to do to come up with this answer. So while this is worth 1 mark, it would be like a long answer question of more than just 1. All right, so let's take a look. What is the tension in the rope? To find the tension, we first have to find the acceleration. We have to go through the proper solving of this. So let's set up a direction. This is going to be positive. We're going to have a force of gravity going down. We're going to have a force of tension here. We're going to have a force of tension here. We're going to have a force of gravity. We're going to have a normal force. And then we're going to have a force of friction. All right, so this force of gravity is mg, so that's 5.1 times our 9.8. That's equal to 50 newtons. The force of friction, mu Fn, mu mg. And so our m is 12 times our 9.8 times our 0.45. Nope. Try that again. Sorry, 12 times our 9.8 times our 0.2. And the force of friction is 23.5. So if we want to find the acceleration, first of all, we're going to take the forces along the string. So F net is equal to ma. F net, so we're going to have our force of gravity plus a force of tension that's negative plus a positive force of tension plus a force of friction, which is negative, and that's equal to our total mass times our acceleration. Well, these two forces of tension add up to 0. So then we're going to have 50 plus a negative 23.5. That's going to equal a total of 17.1 kilograms times our acceleration. And so 50 minus 23.5 is equal to 26.5 divided by 17.1, and that's equal to 1.5 meters per second squared. All right, so I'm going to take a look at this mass, and again, F net is equal to ma. So we're going to have our, not what I was going to say. So we're going to have our force of gravity plus a negative force of tension is equal to our mass, which is 5.1, times our acceleration, which is 1.5. Our force of gravity being 50 newtons. And so this 5.1 times 1.5 is equal to 7.65. That's going to come over as a negative value. And we'll have our force of tension over on the other side. So we get force of tension is equal to 42 newtons. So that's C. You can pause it, you can back it up, you can watch it over again. All right. Sir, we haven't done one like these before. Yeah, that's okay. A string on a mass, a string with a mass on each end hangs over a frictionless peg, frictionless pulley shown in the diagram. The acceleration of the system is, well, this is 2 kilograms, this is 1 kilogram. We know that this direction would best be positive. And all we've done is taken this mass that was up on a table and we just hung it down. Same sort of issues are going to be coming on. So we're here, we're going to have a force of gravity. We're going to have a tension force. Over here, we're going to have a force of gravity. Let's call this 2, call this 1. And we're going to have a tension force here as well. So we're going to take this direction to be positive, and we want to find the acceleration. So we're just going to go F net is equal to ma. We'll sum up our forces along this string. So we'll have a force of gravity 1 plus a force of tension, which is negative, plus a force of tension, which is in the positive direction, plus a force of gravity 2, which is a negative value, and that's equal to our total mass times our acceleration. So we have 2 times 9.8, so this is going to be 19.6 newtons. These add up to give us 0. We have 1 times 9.8, so it's a negative 9.8 newtons. And that's a total of 3 kilograms times our acceleration. So 19.6 plus a negative 9.8 is 9.8. We'll divide that by our 3, and we get a 3.3 meters per second squared. The answer is going to be our C. All right, 22. Here we have our elevator again. Slightly different question happening here. So here we have our elevator, a 700 kilogram elevator. So we have a force of gravity going down. Is suspended by a cable and is accelerating upwards at 3 meters per second squared. The force exerted by the cable is, so here's our force of tension, right? So what we've got here, so our F net is equal to ma. Our force F net, well, that's going to be, and we'll take upwards to be positive. So that's going to be our force of tension plus our force of gravity, which is negative. That's going to equal our mass times our acceleration. Force of tension. Our force of gravity, well, that's going to be 700 times our 9.8. That's our force of gravity. 6,860. And we'll have 700 times the acceleration, which happens to be 3. Just checking my numbers. Okay. So our force of tension then will be 700 times 3, so that's 2,100. Plus our 6,860. Oh, I know what's going wrong. I was thinking, this is not the number I had before. They're telling us to use G of 10, which makes our numbers straight more rounder. So we have, this should be 7,000. And so this comes out to be 91,000 newtons. So our tension, the force exerted by the cable is accelerating upwards, is going to be our 9.1 kilonewtons upwards. As I say, I've done this 3 times. This number was not looking like what I was expecting. All right, here we have a car of 1,500 kilograms with an unbalanced force needed to accelerate the car from 5 to 25 meters per second in 10 seconds. So this is a case where they're giving us velocities and time. And so we have to use our kinematics in order to calculate what the acceleration is. So B is equal to V naught plus AT. Final velocity is 25 is equal to 5 plus A times 10 seconds. So we have 25 minus 5 is 20. It's equal to 10A. A is equal to 2 meters per second squared. That's the acceleration. And so our F net is going to be equal to our mass times our acceleration. So that's equal to 1,500 times our acceleration of 2. So that's equal to 3,000 newtons. And so that's going to be answer C. All right, and we go through and we erase. Okay. All right, so here we have a more complex type questions, multiple questions coming off of this. And we can see this is a coupled system. They've labeled, put a bunch of forces on here, a bunch of arrows on here representing forces. They're going to ask us questions. But again, make sure that you're answering the question they're asking. Because the first one is calculate the force of gravity in the 2-kilogram ball. Force of gravity, how do we calculate that? Come on, F is G is equal to mg. Oh, right, so we're going to have 2 kilograms times our 9.8, so that's equal to 19.6 newtons. Force of gravity on this, 19.6 newtons. Then it says, question number 25, which of the arrows represents the force of gravity? You may select more than one answer. All right, so we have 2 objects. We have this hanging object, force of gravity. Well, F represents the force of gravity acting on it. E represents the force of tension pulling it upwards. If we take a look up this here, well, C is going to be our force of gravity. B is our force of tension. This is our normal force, and this would be our force of friction. So, you know, all those times we went through and labeled the forces, this is when we use that. And so C and F would be the correct answers for that. Get rid of this, slide this up. Which of the arrows represents the normal force? Well, normal force, that's D. just what we saw there. Calculate the force of friction on the 2 kilogram block. The coefficient of friction is 0.45. All right, so to calculate the force of friction is equal to mu Fn. Horizontal block, the force of normal will be equal to the force of gravity. So we can say this is mu Fg, which is mu mg. So we'll have 0.45 times 2 times our 9.8. And times 2 times 9.8 equals 8.82 newtons. There's our force of friction. Which of the arrows represents the force of friction? And we'd have to take a look. The force of friction is A. That is the force of friction. Then it says 29, calculate the unbalanced force in newtons on the system. All right. So we're talking F net. We're just wanting the unbalanced force in newtons. So we're going to have the force of gravity plus the force of tension, which is negative, plus a positive force of tension, plus the force of friction, which is going to be negative. The force of gravity, that's 19.6. These add up to give us 0. And then we'll have a negative 8.82, which is the force of friction. And that comes out to be 10.8 newtons. Then it says calculate the acceleration of the 2 kilogram ball. Well, it's a coupled system, so the ball is accelerating at the same rate as the block is, the same rate of what the string is. So this is not really deceptive, but just don't get hung up that they're all accelerating at the same rate. And that's really the key thing. So this is equal to ma. Well, our m is equal to 4. And so we get a value of 2.69. So the answer B. That's the total mass that's accelerating. Here we have our net force. All right, we are close to being done. The acceleration of a moving object is always in the same direction as, well, the answer is the net force. If the net force is slowing something down, then that's the direction of the acceleration. If the net force is causing something to speed up, that's going to be the direction of the acceleration. If there is no net force, there is no acceleration. All right, go through, cancel this out. And here we go. Oh, right, the submarine. A submarine is traveling underwater at a constant velocity. The acceleration is equal to 0, means the net force is equal to 0. The answer is going to be D. The force is balanced. The force that's causing it to sink, the force that's causing it up, those are going to be equal to each other. The force moving forward is going to be the force of drag going against it. Here, what's happening? Well, it's sinking, but you're also missing the drag. Here, this would be more realistic. We're accelerating forwards horizontally. Here, we're slowing down. We're just coming to, so we're not pushing ourselves forward. We're just slowing to a stop. And this just makes no sense whatsoever. So the best answer, we're at constant velocity and so on, all the forces are balanced. All right. Here we go. Question number 33. Question number 33, the block in the following diagram is being pulled by 2 ropes, 9 and 3. Determine the mass if it accelerates at 1.2 meters per second. All right, so F net is equal to ma. So we're going to have this direction as being positive. So our F net is going to be 9 plus a negative 3 newtons. This is going to be our mass times our acceleration, which is 1.2 meters per second squared. 9 plus -3, that's equal to 6. We're going to divide that by 1.2. That will be our mass. And that works out to be 5.0 kilograms. There you go. Hopefully you're getting a chance to take a look at this. Third time's a charm. Not quite at the end of my day, but it's taken a long time to get here. All right, ladies and gentlemen, it's been a slice, and all the best. Now, how do I turn this off? Stop live streaming. There we go.